Okay, previously we have learned all the necessary functions in ZW3D to create a sheet metal part. So next, we will take a typical part to show you how to design it properly. Alright, this is the case here. Through this case, we can cover most of the functions, such as the full flange, partial flange, HEM, dimple, lower, punch, and etc. And now let's quickly go through the steps to create such a part. So first is to create the base and the full flange. And next, we create the partial flange based on the full flange. And then we can create the taper and also some holes. And the next, we can create the dimple and also the louvers. And finally, we can get the part. Okay, now let's move over to the software to create the simple part. Okay, next I'll use this case as an example to show you the workflow of the sheet metal design. And in this case, I will cover most of the functions in the sheet metal module. And now let's get started. First, create a part. And then, as I mentioned before, we need to predefine the global values of the sheet metal design. For example, we can choose the key factor, we can change it bigger, and also the relief, the ratio. And for the corner, we just keep it by default. And okay, we can update all configuration checked. Now we accept. And first, we need to create the base. Extrude tab, and we draw the profile of the base. First is a rectangle. Okay, and then we draw a polygon. Okay, and then we make some constraints. Vertical for this line. Okay, and also the length and the width of the rectangle. Okay, now we exit. And okay, now the tab is created. And then next we create a full flange to the edge of the rectangle. Okay, and we select the edge one and the other one. Okay, and for this flange, we can use the S-bend. Okay, and also for the position, we can also make it okay, offset 10. Okay, now it looks good. Okay, and the relief is already created. Okay, I think there's no other settings to go. Okay, and next we need to create another full flange for the side faces. Okay, so that is 2 and the length 45. Okay, okay, and continue. We need to create another one full flange, another full flange. Also the length will make it shorter, 15. Okay, and continue. We need to make HEM flange. Okay, this is for the handle, and here we use the open loop. And in this area, we need to just make the partial for this edge. Okay, start and the width, we set it separately. Okay, now it looks good. And we apply it. Okay, everything is fine. We can choose apply it and continue to make another one. Okay, now the HEM flange is created. And next, we need to make a partial flange. Okay, we select the partial flange. Also, we need to select the start and the width, and also the length. Okay, apply and create for the other edge. Flap the direction. Okay, now it's created. And next, we need to create another HEM flange here. And this time, we select the both flanges and we use the closed type. And for the length, we keep it by default. Okay. And continue, we can make a full flange to the two sides. Okay, one, and we create this one, and we make the profile different from the default. We make a slot here. Okay, 2, and also we can make the dimensions 8, also 10. Okay, and continue. We can make it a well-defined 25, and okay. For the length, also we make it well-defined, and we can make the fillet. Okay, make it smaller. Okay. Okay, now we can exit the sketch. Now we already made the flange by customize profile. Okay. And for the other side, we can just use the pattern feature, the mirror feature, to accomplish it. Okay, now it's good. And let's continue. Can make the full flange for the other side. And for the length, okay, 35. Okay. And for these two flanges, we can use the bend taper command. First, we can extend a little bit. Extend by distance 5 mm. Repeat it. Okay, now it looks good. And now we are ready to taper the bend. We select the bend, and we need to make a different direction. And we use it the same metric. Okay, set back 5. This is good. Okay, and the other bend we also make it. Okay, and maybe we can make the bend type different. We can redefine it, and we use the face. Now you can see the adjacent web will be also tapered. It will create more space. Okay. Now we can continue. We can create the dimple feature. And again, we make a circle here. The radius, make it 4 or 3. Okay. And maybe we can define the dimensions to define the position of the dimple. Okay, 10. Okay, and we also mirror it to the other side. Okay, now we exit and create dimple, select the plan and the profile. And here we use the other side. We flap it, and we need to flare the hole. Okay. Now we get a result. Now we can check it if the result is what we want. Okay, now you can see maybe the length is a little bit bigger. We can redefine it to make it a smaller value, 5. Okay, now it looks good. Now we can continue to create the lower on the side flange. And we create the path of the lower. Just simply draw a line. And the length, we make it 25, okay. And okay. We better make it well defined. Okay, now we can exit the sketch. Okay, for the parameters, we can keep it default. Okay, now we get a result. And we use the pattern feature to create more flanges. Okay, like the spacing, we make it 15. And number, we try 10. Maybe we can go more. Okay, now it's good. Okay, and next we can make a punch to the other side flange. And here we select the punch shape from the library. English rib, and we use the round lip. Okay, and first we select the base to be punched from. And then we define the position of the punch shape. We use the constraints way. And we add constraints with two face, flap direction. Okay, and add more constraint. And we'll make the side face of the punch shape and the shape and the plan of the flange to be coincident. And okay, and maybe a little bit offset from the side. Okay, now 20 is good. And we can drag it down. Okay, now the position is quite good. We can just click OK to get the result. Okay, now you can see the result is already created. And now we can create a hole to the flange. Okay, we can draw some circles. Okay, we can define the position by dimensions. 20, 12, and center to the side. Okay, now it's well defined. Okay, and now we can mirror it to make 4 holes. Okay, now we can exit, and we use the extrude cut to make the holes. And we flap the direction and choose the cut option. Okay, now it's good. And by now the sheet metal part is already created. Next we can unfold it. Okay, now we can check the result. Okay, actually it's no problem. And we can use the flatten. Okay, maybe we can redefine the direction to see it more normal. Direction, we can choose the 0, we can choose the negative of the Z direction, and the offset, stationary, all clear. We can click OK. Okay, so this is the flat solid, also the flat pattern. Okay, now we can go the we can go to the 2D sheet environment. We select a template. And first we make the pattern view, the flatten view. And remember to check this option to show the bend line. Okay. And now we can you can see some of the dimensions are a little bit messy. We can adjust it manually. Okay, we can just drag it to a new position. Okay, drag it higher. Okay, and maybe we can adjust the scale. Okay, now the view is smaller. Okay. And next, we can create a view for the folded status. We use the isometric view. And we can also adjust the scale. Okay. Now it's good, and maybe we can change it to the shaded view. Okay. Now it's clear. Okay, and if necessary, you can add necessary dimensions or annotations to it. Here I will skip this step. Okay, this is all for the sheet metal design.